Alright, today we'll be looking at the kinetic theory of matter and the change of state. Meanwhile, if today is the first time of visiting this channel, do not forget to subscribe so that you can have access to thousands of our videos, and also so you get notified anytime we bring new updates. Now, we already know that matter is made up of very tiny particles, which can be either molecules or ions or atom. These are the three main subparticles that makes up matter. So the assumption of the kinetic theory is that matter consists of energy, and this energy can either be potential energy or kinetic energy. We all know that potential energy is energy that is possessed due to the position of rest, while the kinetic energy is the energy due to what? Motion. This is due to what? Rest, while kinetic energy is due to motion. So now, what does the kinetic theory of matter says? The kinetic theory of matter postulates that the particles of matter are always in a continuous state of motion, and therefore they possess kinetic energy. The particles of matter are always in a continuous state of what? Motion, and therefore they possess kinetic energy. So that is the postulate of the kinetic theory of matter. So that an increase in temperature will lead to an increase in the average kinetic energy of particles. Now, why do we say average kinetic energy? Well, it's an average kinetic energy because in a given system, the energy of the different particles available may vary. And so, at the end of the day, it's going to be about a point. And that point is what we refer to as what? The average kinetic energy of the system. Now, let's look at the states of matter. We have three states of matter, which are the solid state, the liquid state, and the gaseous state. Now, from the kinetic theory of matter, let's look at the solid state. What explanation does the kinetic theory of matter has for the solid state? When particles exist in the solid state, what happens? Now, in the solid state, the particles in the solid state are closely packed together, and they are held together by forces of what? Cohesion. These particles are held together by forces of cohesion. These forces can either be electrovalent, which you should have known from your chemical combination, covalent, metallic, van der Waals, or hydrogen bond. These are different forces of cohesion, intermolecular forces. Now, what happens? The strength of the solid particle of the cohesive forces is determined by the nature of each of these bond that is present. If there is an electrovalent bond that is present, a covalent or metallic, van der Waals or hydrogen bond will determine the strength of the bond. Now, in that solid state, the cohesive forces hold these particles so close together. The particles in the solid state are held very, very close together in a fixed position. In a very fixed position. And because of that, particles in the solid state can only vibrate and what? Rotate. But they cannot translate, like they cannot move from one point to the other. And so because they can vibrate and rotate, they possess what? kinetic energy, because we say kinetic energy is energy due to what? Motion. And so because there is motion here in vibration and rotation, these are all types of motion. Vibratory motion and rotational motion. And therefore, this we ascribe a type of kinetic energy to the system. Now, because of this, the solid state has a fixed volume. It has a definite shape. But because the forces have already held themselves so closely, it cannot, they are what? Incompressible. You cannot compress a solid. For example, wood now. You want to compress a wood, it's already in the solid state. The particles are closely packed already, and the cohesive forces are strong. So therefore, you cannot reduce it to a smaller volume. Hence, we say they have a definite volume, definite shape, and they are what? Incompressible. Now, in the liquid state, also the particles present are also held together by forces, by cohesive forces, by forces of attraction, by cohesive forces. But these forces are weaker or more elastic than the forces in the solid state. So in the liquid state, because of these weaker forces, the particles can vibrate, they can rotate, and they can what? Translate. So unlike the solid state, the particles in the liquid state can translate, while those in the solid state cannot translate. And because of that, particles in the liquid state have definite volume. But because they can move about, that is translational motion, moving from one point to the other, they do not have a definite shape. They assume the shape of the what? Container. So if you put it in a cup, the liquid will take the shape of the cup. Put it in a bottle, it takes the shape of the bottle. They have no definite shape. And a liquid can be what? Compressed a little. Unlike the solid that is hard to compress, a liquid can be compressed. Let's look at the gaseous state. In a gaseous state, the forces of attraction between the particles are negligible. And because of that, the particles move randomly. They move from one point to the other, colliding with themselves at great speed and the walls of the containing vessels. And because of that, particles in the solid state, they do not have, in the gaseous state rather, they do not have a definite volume. They do not have a definite shape, and they are highly compressible. This is because there is negligible forces of attraction between the particles in what? In the gaseous state. So that is it about the kinetic theory of matter and the change of state. Do not forget to subscribe to the channel.